Welcome YouTubers to another episode in my Grammar Hero series. In this video, I'm going to show you how to solve some of the most challenging questions that will appear on the ASVAB. Please keep in mind that since the ASVAB is a computer adaptive test, you only see some of these questions if you're going to score somewhere between 70 and 99 on the test. Similarly, I want to stress again that you only see a handful of these problems, not all of them. Otherwise, it would take you a very long time to finish the test. All that said, let's go ahead and get started with today's video. This first question says, suppose your grades on 3 math exams are 80, 93, and 91. What grade would you need on your next exam to have at least a 90 average on the 4 exams? So to start, I want to point out that the average is the sum of all the data points you're given divided by the total number of data points. So in this case, we know we have 1, 2, 3, and a 4th unknown data point, which I'm going to represent as x. And what's more, we also know what our average has to be. According to the problem, our average has to be a 90. So let's go ahead and set this problem up. Average, which I'm just going to write as AVG, is equal to sum over the total number of data points. In this case, we can go ahead and start filling things in accordingly. So we know our average has to be 90, so let's plug that in for average. Similarly, we know all of our data points. We have 80 plus 93 plus 91 plus the unknown data point, which we represented as x, over how many data points there are. There are 1, 2, 3, 4, including the unknown 1. So at this point, we've set this problem up. The only thing left to do is to solve for x. As we can see, we have this big fraction. So ideally, we want to get rid of it. To do that, we're going to multiply both sides by 4. And in doing so, that lets us cross this out. 90 times 4 is 360. If you need me to do it off to the side, I can. But a large part of the ASVAB is being able to do mental math where possible. But that said, let's work it out. 0 times 4 is 0. 9 times 4 is 36. Okay, and we're left with this. 80 plus 93 plus 91 plus x. Okay, now we're solving for x. The next thing I like to do to make sure my work stays nice and neat is to combine all these like terms. That is, I'm going to add 93, 80, and 91. The hardest part about this problem is setting it up, and beyond that, doing all your arithmetic correctly. 0 plus 3 plus 1 is 4. 9 plus 9 is 18. Plus 8 is, well, 8 plus 8 would be 24, so 8 plus 18 is going to be 26. So we have 360 equals 264 plus x. And again, we're still solving for x. That is, we're trying to get x by itself. So the next step is to subtract 264 from both sides. This crosses out. This leaves us, and I'm going to rewrite it before I do the math. This leaves us with 360 minus 264. Let's go ahead and work that out in case we can't do it mentally. 264 minus, or 360 minus 264. 0 minus 4 we can't do. We have to borrow. This becomes 5. This becomes 10. 10 minus 4 is 6. 5 minus 6 we can't do. We have to borrow. This becomes 2. This becomes 15. 15 minus 6 is 9. 2 minus 2 is 0. Therefore, we know x is 96. In other words, to have a 90 average on the 4 exams, you must score a 96 on your 4th exam. Okay, so that's this one. you will likely see a problem like this on the ASVAB. This is a very common problem that most people will see. Okay, so and in all honesty, this is one of the easier problems in this video. Please know how to do this one. Once you know how to do it, you'll get this problem right every single time. Alright, so question 2 says, a class of 25 students took a science test. 10 students had an average score of 80. The other remaining students had an average score of 60. What is the average score of the whole class? So this problem is an average problem. Specifically, it's called a weighted average problem. And to solve it, you take a very similar approach to what you did in the previous problem. That is, we're going to find the sum of all the individual data points, which are exam scores in this case, and divide it by the total number of data points. So in this case, there are 25 exam grades, and now we have to figure out what we're going to put in the numerator. Well, it turns out this is pretty straightforward. 10 students scored an 80, so that's going to be 10 times 80. And then the remaining students, again, let me point this out. 25 minus 10 is 15, so the 15 remaining students scored a 60. And so this is how we set up this average problem. 10 times 80 plus 15 times 60 divided by 25. Again, weighted average. So let's go ahead and keep working it out. 10 times 8 is 800. 15 times 6, in case you can't do that one mentally, let's work it off to the side. 0 times 5 is 0. 6 times 5 is 30. Before we start multiplication with this 1, we have to drop down a 0. 1 times 0 is 0. 1 times 6 is 6. 300 plus 600 is 900. So this is 800 plus 900 divided by 25. 800 plus 900 is 1700. Again, that's divided by 25. Now we have to do the long division. Again, all fractions can be regarded as long division. 1700 divided by 25 is going to be this. 1700 divided by 25. Now we ask ourselves, how many times does 25 go into 1? It can't. How many times does 25 go into 17? It doesn't. How many times does 25 go into 170 without going over? 25 goes into 104 times, 125 5 times, 150 6 times. So we know this is going to be 6. Insofar as 25 times 6 is 150. 170 minus 150 is 20. Drop down this 2. 25 goes into 200 8 times without going over. 25 times 8 is 200, so we can see there's going to be no remainder. Therefore, we know the class average, the weighted class average on this exam was a 68. Now, just to point this out, this kind of looks like this. Just take 80 and add it 10 times. That's what that would look like. So it is the same as doing an average. Instead of adding all this 8 times or 10 times, you're just doing multiplication and leaving it at that. Instead of adding 60 together 15 times, you're just doing the multiplication and leaving it at that. Okay? You may see a weighted average problem on the ASVAB. I think I did, so just be prepared. Use the same formula. Instead of doing addition in the numerator, you have to do multiplication. Okay, the ASVAB likes these age questions, so let's take a look at this one. Karen is twice as old as Lori. 3 years from now, the sum of their ages will be 42. How old is Karen? So to solve these problems, you just have to translate the word problem into an algebraic equation. Karen is twice as old as Lori. So I'm going to say Lori is X years old, which means Karen is 2X years old. 3 years from now, the sum of their ages will be 42. So this is now, and this is going to be 3 years. In 3 years, Lori's going to be x plus 3 years. And in 3 years, Karen's going to be 2x plus 3 years. Okay, so now we have to use this final part. The sum of their ages will be 42 3 years from now. How old is Karen now? So if 3 years from now the sum of their ages is 42, that means this: x plus 3, Lori's age 3 years from now, plus Karen's age 3 years from now, 2x plus 3, will be 42. Now we're just solving for x. Let's combine like terms, namely x and 2x. 2x plus x is 3x. 3 plus 3 is 6. Of course, this equals 42. We're solving for x now, as we can see. So we're going to try to get x by itself. The first thing I'm going to do is subtract 6 from both sides. This crosses out. I'm left with 3x equals 42 minus 6. 42 minus 2 would be 40. Minus 4 more would be 36. Divide both sides by 3. That leaves us with x equals 36 divided by 3. 3 goes into 3 one time. 3 goes into 6 two times. So x equals 12. The question asks us, how old is Karen now? Again, when I set this problem up, I said x represented Lori's age. So right now, Lori is 12. Karen is twice as old as Lori now. 2 times 12 is 24. Okay? So just some very basic algebra for this problem. A lot of people would get stuck right here. If you got stuck right there, just bear in mind that you could put fake values in this problem to kind of figure out what this should be. So for example, if you got stuck with writing this equation here, let's say you said Lori was 5, that means Karen would be 10. 3 years from now, that would be 8. And then you would have to write an equation that would make this 13. But as you can see, 5 times 2 plus 3 is 13, which means it works. Okay, so if you ever get stuck, you can put real values in here just to make sure your formulas work. But that said, this one's pretty straightforward. Alright, this question says one pump by itself can fill a tank in 24 hours. Another pump by itself can fill the same tank in 40 hours. How long will it take to fill the tank if both pumps are used to fill the tank together? Okay, so this is a fairly common question on the ASVAB. It's called a combined work problem, and there's a key to setting these up, and that is to think about how much work each pump can do individually. If one pump can fill a tank in 24 hours, that means it can do 1/24 amount of work per hour, and we could represent that as this, and we're going to use t as our variable since we're referring to time. How long will it take? So we're going to use t as our variable. One pump can fill the tank in 24 hours. That means in every hour it fills 1/24. It fills 1/24 of the tank. Another pump can fill the same tank in 40 hours. That means every hour it fills 1/40 of the tank. Okay? The question is, when you combine these two rates of work, how long will it take to fill the tank completely? So this is how you set it up. 1/24 times t plus 1/40 times t equals 1 tank. Again, this refers to filling 1/24 of the tank per hour times time plus 1/40 of the tank per hour times time equals 1 full tank. No matter what you see, no matter what these variables are, if you identify that you have a combined work problem, this is how you set them up. Okay? You're always going to set them up this way. That said, it presents us with a new problem because now we have to deal with these fractions. I'm going to go ahead and place this variable t over the fraction. So this is going to be t over 40 and t over 24 equals 1. To add fractions, you have to ensure that the denominators are the same. In this case, we have 24 and 40, so we can't add them just yet. So I'm going to start listing out factors of 40. We got 40, 80, 120, 160, and so on. Let's start listing out factors of 24. 24, 48, and for some problems you're going to have to do this on the ASVAB. 8 plus 24, 8, 9, 10, 11, 12, 2, 6, 72, 4 plus 2 is 6, 7, 8, 9, 4 plus 6 is 10, carry the 1, so 9 plus 3, 9, 10, 11, 12. And as you can see, we have a common factor of 120. This is the 1, 2, third factor, and this is the 1, 2, 3, 4, fifth factor. So to put these over the same denominator, I'm going to multiply this one by 5 over 5, and I'm going to multiply this one by a common factor of 3 over 3. 5 times 5t is 5t. 5 times 24 is 120. T times 3 is 3t. T times 40 is 120. Again, this all equals 1. Let's go ahead and add these fractions now. 5t plus 3t is 8t over 120 equals 1. Again, we're trying to solve for t, so we got to get rid of this 120 as the next step. I'm going to multiply both sides by 120. And so doing this crosses out. That leaves me with 8t equals 1 times 120. Anything times 1 is itself, so we know that's 120. I'm going to divide both sides, and let me rewrite this here. 8t equals 120. Let's divide both sides by 8 to get t by itself. This crosses out. We're left with t equals 120 divided by 8. So let's go ahead and do that division. 120 divided by 8. 8 goes into 12 one time without going over. 8 times 1 is 8. 12 minus 8, 8, 9, 10, 11, 12. That's 4. Drop down this 0. 8 goes into 40 5 times without going over. 8 times 5 is 40, so we can see there's no remainder. In other words, it will take the pumps, if they're both operating together, 15 hours to fill this one tank. And again, that's this pump working at filling the tank in 24 hours and this one filling it in 40 hours. Okay, so that's this one. Again, this is how you set up these combined rate problems. You write them over 1, you add the variable time in there, and you set them equal to 1. So that's that one. Again, this is another combined rate problem. It says if Sally can paint a house in 4 hours and John can paint the same house in 6 hours, how long will it take for both of them to paint a house together? Again, if Sally can paint the house in 4 hours, she can paint 1 over 4 of the house per hour. And if John similarly can paint the house in 6 hours, he can paint 1 over 6 of the house per hour. Add our variable t in there and set this equal to 1. This equation says if Sally can paint 1/4 of the house per hour and John can paint 1/6 of the house per hour, how long will it take them working together to paint the entire house, which I represent as 1? Like in the last problem, we have denominators, and again, let's go ahead and throw these variables over, or put the variables in the numerator. So like in the last problem, we have denominators that are different. So before we can add these things together, we have to make the denominators the same. So let's go ahead and think about how we're going to do that. Fortunately enough, it's fairly easy to do these. We know a common factor is going to be 24. 4 goes into 24 6 times, so we know this is going to be 6t. 6 goes into 24 4 times, so we know this is going to be 4t. Let's go ahead and add these together, and I'm going to move over here. 6t plus 4t is 10t all over 24 equals 1. Again, we're trying to solve for t by itself, so I'm going to multiply this side by 24 and this side by 24. This crosses out. I'm left with 10t equals 24. Divide both sides by 10 to get t by itself. This crosses out. We're left with t equals 24 divided by 10. So whenever you divide something by a power of 10, which can be 10, 100, 100, 100, 1,000, 100,000, and so on, you simply take the decimal and shift it to the left, however many zeros there are in the power of 10. In 10, there's 1 0. So I'm going to take this decimal and shift it to the left once. So I know 24 divided by 10 is going to be 2.4. In other words, if Sally and John paint the house together, it will take them 2.4 hours to do it. So that's that one. Again, same setup as the last combined work problem. So you should definitely know how to do those. Okay, so this next question says 2 students leave the school at the same time and travel in opposite directions along the same road. One walks at a rate of 3 miles per hour. The other bikes at a rate of 8.5 miles per hour. After how long will they be 23 miles apart? So I like to draw diagrams to solve these. We have this one student. He's walking this way at 3 miles per hour. This student leaves at the same point, and they're heading in the opposite direction, albeit at a rate of 8 miles per hour. The question is, how long will it take them to be 23 miles apart? So it turns out that the ASVAB is very big on testing your knowledge of how to use distance, rate, and time, or how to solve for distance, rate, and time. And it throws a lot of different variations at you. It could be something as simple as plugging this information in, but once you start scoring very well on this test, or start doing very well on this test, it's going to give you these problems where the people are heading in opposite directions, the same direction, and so on. So to solve this one, I like to think of it like this. Imagine if you had one person traveling 23 miles, albeit at a combined rate of, and this should be 8.5, not 8, albeit traveling at a combined rate of 8.5 plus 3 miles per hour. 8.5, 9.5, 10.5, 11.5 miles per hour. This is the same problem. Again, 2 people traveling in opposite directions at different speeds but for the same distance, or 1 person traveling a combined rate over the same distance. This is a lot easier to work with. So whenever I get these problems where they're going in opposite or similar directions, I always write it out and then combine the rates and solve accordingly. So now with that done, this actually becomes a very easy problem. Again, we're solving for time, how long. So we know t is going to be our unknown variable. Let's go ahead and rewrite this. Distance equals rate times time. Distance is 23 miles. That was given. The rate is the combined rate of 11.5 miles per hour. Time is unknown. So now we're just solving for t. So I'm going to divide both sides by 11.5 to get t by itself. This crosses out. I'm left with t equals 23 divided by 11.5. That looks like this. 23 divided by 11.5. And now we're trying to do long division, albeit with a decimal outside the division bracket. The key to doing long division with decimals is this. If the decimal's inside the division bracket, you don't have to worry about shifting anything. If, however, the decimal's outside the division bracket, you have to shift the decimal such that the number outside the division bracket becomes a whole number. And then you have to shift the decimal inside the division bracket a corresponding number of times. Technically, there's a decimal right here. 11.5 is, to make that a whole number, we have to shift this decimal one time. And I'm going to do that a corresponding number of times inside the division bracket. And I'm going to add a 0 where necessary. So in reality, this problem is this. 115 or 230 divided by 115. I'm going to go on a limb and say 115 goes into 232 times, but let's confirm that. 5 times 2 is 10. Carry the 1. 2 times 1 is 2, plus 1 is 3. 2 times 1 is 2. So we can see that 115 times 2 gives you 230 exactly. So there's no remainder. In other words, it would take 2 hours for these two students to be 23 miles apart. Okay? So again, this is a distance problem. It's a slightly more challenging distance problem because you're given two different speeds and the fact that they're traveling in different directions. I have a whole video devoted to distance, rate, and time problems on my channel. So if you need more practice with distance, rate, and time, go ahead and check that out. But in general, the key is to take a challenging problem, simplify it, and then plug it into the distance, rate, and time formula, and then the math becomes very simple. So that's that one. Now this is one of the most challenging problems you'll probably see on the ASVAB. It's also a distance, rate, and time problem, and it says this. Flying against the jet stream, a jet travels 1,880 miles in 4 hours. Flying with the jet stream, the same jet travels 5,820 miles in 6 hours. What is the rate of the jet in still air? And what is the rate of the jet stream? When you get a lot of these different conditions, you want to set up a chart. And again, we're using distance equals rate times time to solve this one. That said, we have an unknown variable, namely the jet stream, flying against it and with it. I'm going to represent jet stream with a new variable j. And if you think about it, the jet stream, when you're flying with it, speeds you up. So that's going to be j plus r. And when you're flying against it, the jet stream slows you down. And let me rewrite that. It's going to be r plus j because it's speeding your rate of speed up. And when you're flying against it, it slows you down. So I'm going to represent that as r minus j. Okay? With that, let's go ahead and set up a table here for the two conditions that we have. And I'm going to call this against, and this with. And I need another bracket here. Okay, so I'm going to let this be our rate, time, and distance. Okay? So when you're flying against the jet stream, as I just mentioned, it slows your rate of speed down. So we're going to represent that as r minus j. When you're flying with it, it speeds you up. So we're going to call that r plus j. Time is what we're trying to... Time is given. So against, we're told it takes 4 hours to cover 1,880 miles. And with the jet stream, we're told it takes 6 hours to cover 5,820 miles. And so now we have all this information we can use to solve. Again, what I want to do is take this and write it into two equations that I can set up a system of equations for. So I'm going to do this. And again, we're going to use distance rate times time. But to make this easier, I'm going to do rate times time equals distance. Again, it's the same thing. I just took this and shifted it over there. Okay? So again, we're going to use rate times time equals distance. It's the same formula as the distance formula, just rewritten. And let's go ahead and set this up for our two conditions. Again, condition 1 is against. We know our rate is r minus j because it's going against the jet stream. We know the time is 4 hours, and we know the distance, which was given to us in the problem, is 1880. Similarly, with the jet stream, we know that rate is going to be r plus j. We know the time is 6 hours, and we know the distance similarly is 5,820. So now we have what looks close to a system of equations that we can use to solve this problem. What you could do is multiply this 4 to this r and this j, and multiply this 6 to this r and the j. Or you can simplify this problem as your next step by dividing this side by 4 and this side by 4. This will get rid of this 4 and leave you with just r and j. And if you divide this side by 6 and this side by 6, this crosses out and leaves you with r plus j. Let's go ahead and do that. Again, I'm dividing this side by 4 and this side by 4. That leaves me with r minus j equals 1880 divided by 4. I can't do that in my head, so let's work it off to the side here. 4 goes into 18 4 times without going over. 4 times 4 is 16. Subtract 18 minus 16 is 2. Drop down this 8. Drop down this 0. 4 goes into 28 7 times. Therefore, 4 goes into 280 70 times. 4 times 70 is going to be 280. So there's going to be no remainder there. So this simplifies to r minus j equals 470. And let's go ahead and do this one now. 5,820 divided by 6. 6 doesn't go into 5. How many times does 6 go into 58? 6 times 10 would be 60, so we know that's going to be too big, so this has to be 9. 9 times 6 is 54. Subtract accordingly. 58 minus 54 is 4. Drop down this 2. Drop down this 0. 6 goes into 42 7 times, therefore 6 goes into 420 70 times. 70 times 6 would be 420, so there's no remainder there. So this is r plus j equals 970. And now we have a system of equations we can use to solve this. And let me go ahead and work out this system over here. To solve for systems of equations, you have to get rid of one of the variables. And in this case, we have r minus j equals 470. R plus j equals 970. We have to figure out how we're going to rewrite one of these equations to get rid of one of the variables. As you can see, if you add this first equation to this, or this second equation to this first equation, you'll get rid of j. So that's what we're going to do. We're going to rewrite this first equation by adding r minus j equals 470 plus r plus j equals 970. Let's add. R plus r is 2r. J, negative j plus positive j is nothing. And then we have 470 plus 970. 0 plus 0 is 0. 7 plus 7 is 14. Carry the 1. 9 times 4 is 13, plus 1 is 14. So this gives us 2r equals 1440. We're solving for r, so we're going to divide both sides by 2, not r. This tells us r equals 1440 divided by 2. Let's work that out. 1440 divided by 2. 2 goes into 14 7 times. 2 goes into 40 20 times. So what this tells us is the rate of the jet in still air. So to answer the first part of this question, the rate of the jet in still air would be 720 miles per hour. To answer the second part of the question, the speed of the jet stream, we have to plug this r into one of these two equations and solve. Let's go ahead and plug it into this second one. Again, r is 720, so this becomes 720 plus j. J refers to the speed of the jet stream, equals 970. We're solving for j, so we're going to subtract 720 from both sides. J equals 970 minus 720. 0 minus 0 is 0. 7 minus 2 is 5. 9 minus 7 is 2. Therefore, we know the speed of the jet stream is 250 miles per hour. And now we've solved for everything they've asked. In general, this question is asked using one of two variables, either jets or the speed of water, the speed of a boat in a stream going upstream and downstream. Either way, you set up this chart and you solve accordingly. Again, I have a whole video on distance, rate, and time. And if you want to see the problem done, albeit for the speed of boats traveling with the stream and against the stream, look for the video I have titled The Hardest Problem on the ASVAB. That's the same problem, albeit with boats. So you may want to take a look at that. This is probably one of the hardest questions you'll see on the ASVAB. I saw it. I got it right. And it took a lot of work. But that said, if you're going to score 90 or above, you should be prepared to deal with something like this at least once. All right. This question says, peanuts sell for $3 per pound. Cashews sell for $6 per pound. How many pounds of cashews should be mixed with 12 pounds of peanuts to obtain a mixture that sells for $4 per pound? Okay, so this is a mixture problem. These, in my opinion, are very challenging. But that said, like in the last problem, we're going to use a chart to keep our work organized. And this chart's going to have three things in it. It's going to have peanuts, cashews, and the mix. Okay, and this is going to be the cost, the pounds, and the total. We're told peanuts cost $3 per pound. In this case, we're told that we're given 12 pounds of peanuts, so we can fill that in. And this becomes 3 times 12, which is 36. Okay. Cashews are $6 per pound. We're being asked to find how many pounds we should mix, so that pound is unknown. This total is going to be 6 times x, which is 6x. The mix, we're told, is going to be $4 per pound. The number of pounds is going to be this. Let's see, it's going to be 36 plus 6x. Again, this is the total pounds. It's the... Oh, no, not 36. It's going to be the 12 pounds of peanuts plus the unknown amount of pounds of cashews. And then finally, the total is going to be 4 times 12 plus x. Okay? Again, we're trying to solve for this mix, so this is how we're going to do it. We're going to set it up like this. The total amount of peanuts is going to be 36 plus the unknown amount of cashews, which is going to be 6x. It's going to equal 412 plus x. Again, I just took this row, I added the first one to the second one, I added the amount of peanuts to the total amount of cashews, and I know that's going to equal our total amount of mix. And that's how I came up with this formula. Now all you have to do is solve for x. So we got 4 times 12, and I'm going to distribute this 4 here and here. So let's just rewrite this. 36 plus 6x equals 4 times 12 is going to be 48 plus 4 times x, which is 4x. Again, we're solving for x. So I'm going to subtract this 4 from both sides. 4x minus 4x is nothing. 6x minus x is 2x. Then I'm going to subtract 36 from both sides. This crosses out. 48 minus 36 is going to be 12. Again, we're solving for x, so we're going to divide both sides by 2. This leaves us with x equals 12 divided by 2, which is 6. So in other words, you have to mix 12 pounds of peanuts with 6 pounds of cashews to get a mixture that sells for $4 per pound. Again, I don't like these problems. They're one of the problems that I have a blind spot for. Unless I set up this chart and work my way through it, I have a very hard time with these problems. But that said, just set up this chart and you should be fine. Chances are you're not going to see a problem type like this, but you may. Alright, 2 more questions. Alright, this question says you need a 15% acid solution for a certain test, but your supplier only ships a 10% solution and a 30% solution. Rather than pay the hefty surcharge to have the supplier make the 15% solution, you decide to mix 10% solution with 30% solution to make your own 15% solution. You need 10 liters of the 15% acid solution. How many liters of 10% solution and 30% solution should you use? Okay, so let me get my pen back. I'm going to call this 30% solution strong, S, and this 10% solution the weak solution. And the first thing I want to write down is this. The weak solution plus the strong solution is going to be equal to the 15% solution. Okay? And similarly, I want to point out that I did that wrong. The weak solution plus the strong solution is going to combine to 10 liters of the 15% solution. So weak plus strong, however many liters you need of each, equals 10 liters in total. Now let's add the percentages. We got 10% of the weak solution plus 30% of the strong solution is going to equal 10 liters times the 15% of the mixed solution. Let's keep working this out. 10W plus 30S equals 10 times 15 is 150. Okay? So as you can see, we've set up an equation to solve this one, but that said, we have 2 different variables, namely 10W, 30S. And the question is, how are we going to solve this with 2 different variables? Well, right here, when I wrote this down, the weak solution plus the strong solution is going to equal to 10 liters total. I can rewrite this to be Let's see which one do we want to do. I can rewrite this so that I can have W, the weak solution, equals 10 minus S. Again, I just subtracted S from both sides, so W equals 10 minus S. Then I can take this W and plug it in right there for W, so that I can rewrite this as 10. And again, I'm rewriting W with this, 10 minus S plus 30S equals 150. And now we can solve. We have all the same variables, so this one's not going to be that difficult. 10 times 10 is 100. 10 times negative S is negative 10S plus 30S equals 150. Let's combine like terms. Negative 10S and 30S is 20S plus 100 equals 150. Subtract 100 from both sides to get S by itself. This crosses out. We're left with 20S equals 100 minus 150 is 50. Let's divide both sides by 20 to get S by itself. S equals 50 divided by 20. 5 divided by 2 would be, and we can cross these zeros out to make this 5 divided by 2. 5 divided by 2 is 2.5. So in other words, we need 2.5 liters of the strong solution. Again, in total, we need 10 liters. So if we have 2.5 liters of the strong solution, that means we need 7.5 liters of the weak solution. Okay? 7.5 plus 2.5 equals 10, and I can write that as this. 7.5 plus 2.5 equals 10. Again, this is the weak solution, this is the strong solution. You can see that we have the correct combination of solutions to equal 10 liters, and so we're done with this one. Again, these combined mixture problems are very difficult for some people. Some people are very good at them. Again, the key is to either set up a chart or to do a small algebra trick like this to solve. Either way, these are difficult problems. Alright, this final question says you're running a concession stand at a basketball game. You're selling hot dogs and sodas. Each hot dog costs $1.50 and each soda costs 50 cents. At the end of the night, need a comma there, you make a total of $78.50. You sold a total of 87 hot dogs and sodas combined. You must report the number of hot dogs and sold and the number of sodas sold. How many hot dogs were sold and how many sodas were sold? So this one is actually pretty straightforward once you understand what it's asking. Hot dog I'm going to call H, and soda I'm going to refer to as S. It's going to be my two variables. We know hot dogs cost $1.50 each, so that's going to be 1.5 H. And sodas are 50 cents each, so I'm going to call that 0.5 S. We know in total we sold $78.50 worth of hot dog and sodas. And similarly, we also know that we sold a total of 87 hot dogs and sodas combined. So H plus S equals 87. Right here, we've set up a system of equations. And as we did in the problem with the plane flying with and against the jet stream, we can go ahead and solve this one by trying to eliminate a variable. In this case, I'm going to multiply this equation by negative 0.15, and then I'm going to add it to this first equation, which is going to eliminate this 0.5s. So let's go ahead and just take it one step at a time. Negative 0.5h. Negative 0.5 times h is negative 0.5h. Negative 0.5 times s is negative 0.5s. And finally, negative 0.5 times 87. Let's go ahead and work that out. In this case, we're doing multiplication with a whole number times a decimal. To do multiplication with a whole number times a decimal, you shift this decimal one time to make this whole number, to make this decimal a whole number, and at the very end we're going to shift the decimal back into the left. So in reality, instead of doing 87 times 0.5, I'm doing 87 times 5, albeit with one decimal to shift back in. 7 times 5 is 35, carry the 3. 8 times 5 is 40, plus 3 is 43. Shift our one decimal back in. So this is negative 43.5. And as I said, to get rid of this variable s, I'm going to take this new equation and I'm going to add it to this first equation. So that's going to look like this. 1.5h plus 0.5s equals 7850. And let me get rid of this arithmetic here. So we can have some room to do the work. We're going to add this new equation there. Negative 0.5h minus 0.5s equals negative 43.5. Okay, let's add these equations. 1.5 plus negative 1.5 is going to just be 1h. 0.5 minus 0.5 is nothing, so we're left with h equals 78.50 minus 43.50. 50 cents minus 50 cents is 0, so all we need is 8 minus 3, which is 5, and 7 minus 4 is 3. Okay, so this is h equals 35. That means there were 35 hot dogs sold. To figure out how many sodas were sold, we're going to use this equation, h plus s equals 87. Again, we know how many hot dogs were sold. We solved that down here. It's 35. So we're going to plug that in right here. 35 plus s equals 87. Solving for s now, we're going to subtract 35 from both sides. 87 minus 35 is 7 minus 2 is 7 minus 5 is 2. 8 minus 3 is 5. So we know s is equal to 52. S is equal to 52. In other words, there were 35 hot dogs sold and 52 sodas sold. And that's how you solve this equation. Again, you set up this problem. You set up a set of system of equations. You get rid of one of the variables, and then you go from there. So that's all I have for you in this video. Honestly, these are the most difficult questions that you'll see on the ASVAB. So if you felt as if I didn't explain something that great, just bear in mind that these questions are hard for everyone, including people who have degrees in math. That said, if you found this video helpful, feel free to give it a thumbs up. In addition, if you find all of my videos helpful, please consider subscribing to my channel, and you can always leave some feedback in the comment section below. But on that note, I'm going to go ahead and cut you loose. Konnichiwa.